Okay, good afternoon, everyone. I hope that I'm audible. Okay, good afternoon, everyone. Can you hear me? Good afternoon. Can you give a thumbs up if you can hear me? Right, okay. Okay. Okay, good afternoon. So you're here with the very first seminar of our GCA O-Level Mathematics Seminar Series. So this will be a testimonial for you to check whether the class is okay to go or better to go with. And you can join for the rest of the seminars that I will be conducting. So I'm Keshala Gunaratna. I'm an undergraduate of University of Sri Jayawardena. Yeah, so today's session would be a free seminar for all of you. From next week onwards, we'll arrange the time that is most suitable for you, and we'll try to allocate the seminars from next week onwards. So we'll have most probably 15 seminars for you to get a thorough idea and to revise papers, past papers, and all of those for the upcoming GSE O-Level examination. Okay, so what I planned for the seminar series is that what we want to do is to, in mathematics, what you need is the practice to do calculations, to do them in time, the time limits. Those are the important things that we have to consider when it comes to mathematics in O-Level exam. Okay. So what I planned is I will be covering a certain lesson or a certain 3 or 4 lessons from your textbooks from grade 10 and 11 together. I will revise the part that you have done already. I think most of you have already covered the entire grade 10 syllabus, and you will be having some parts remaining for grade 11, right? So what I thought was we could divide the 2 syllabuses to separate sessions, and we can revise them with the past paper questions. So that will be easier for you to catch up, okay? Then I'll be revising the lesson first for grade 10 and 11, both now if you take perimeter, today we'll be covering perimeter, surface area, and surface volume. So if you take perimeter is there in grade 10 book as well as in grade 11 book. So we'll be revising everything in those books in a simpler way for you to, remember for a while. And
excuse me, Miss Keshala.
Yes.
This is from Impact Tutoring. Hi students, I am the founder of Impact Tutoring here with you all today. So Miss Keshala here will be covering a very important lesson for you all. So please give your maximum cooperation, because this lesson is a free lesson, so you can invite your friends in as well. And in the near future, we will be bringing up a seminar series where there are both paid and free lessons happening. So if you have any doubts or questions with regards to this, you can always chat in the chat box. And please do not interrupt the lesson in between, because you have a really small time to cover up the lesson. And if you need explanations in other languages, like if you want help in Sinhala, Miss Keshala is also familiar with Sinhala. So if there's a small section that you want help in Sinhala, she is there to help you out. And if you want details about any other session, you can, of course, drop a text onto our WhatsApp. Miss Keshala, you can give our Impact Tutoring WhatsApp number to them, so they can contact us through that. And yeah, so that will be it. If there's anything, please let us know. I will be leaving the meeting. Over to you, Miss Keshala. Have a nice day, guys.
Thank you. So we'll be covering, as I said before, so what we'll be covering is these 3 lessons today. Since it is a free seminar, you can use these 2 hours to get a get a better idea about how we will be doing this, and whether it's efficient or productive to you or not. It is up to you to decide. So I'll be sharing the Impact Tutoring number to the chat box. Until then, we'll be starting the lesson then. So I'll be first covering revising the parts that we have learned in perimeter, surface area, and surface volume. Okay. Then as Ms. Domini said, if anyone has trouble with the language, like if you are not much familiar with English, or some terms, if you need any help in Sinhala, I'll be explaining as well. Then if anyone needs me to explain something in Sinhala, just drop a text to the textbook, okay? All right, then I'll be starting the lesson. And is the board visible enough for you? Is it clear? Like, let me write. Is there any trouble for you to see what's written on the board? Is it clear enough? Just if it is not clear enough, just drop a text. Okay. I hope it is clear. Then our first lesson. Now, you might feel that this is a very easy lesson because you have been doing this ever since you were a kid, right? From grade 3 onwards, I think you will be learning. You should have been learning perimeter. But then again, you might not remember some points in here. And we will be discussing about more complex figures when it comes to grade 10 and grade 11 work. Okay, then I'll be revising everything, and it's better if you can use a sheet of paper. Just use a single half sheet or single A4 paper. Just hold it like this. Then you will have a short note in this lesson. That's much easier. You can fold it and you can start writing from a side. Then you have 4 sides to write. Then you will be having a single sheet of paper for those 3 lessons. Okay? And I think that's easier for you to study when it comes to, when it's near the exams. Okay? Okay, then in perimeter, when you're talking about the perimeter means the entire length that we have outside. Now, if you take a figure like this, you know what it is. It is a square. In a square, all the lengths are equal. Then perimeter is all the lengths around this figure, right? What we can see from outside. Now, if I draw a composite figure like this, now this length we have to take, this length we have to take, this we have to take, this length we have to take when considering the perimeter. But what about this length? If you look through the margin, if you look at the margin, this length is not in the margin. Therefore, you're not supposed to add this length to get the perimeter. Okay, so did you get what I said? Perimeter is the marginal length of a diagram. Okay. All right. Then I'll be discussing about few common diagrams that we learn. Then we have square, as we already know. All the sides are equal there. Then if I write perimeter, P is 4 times A, right? P is 4 times A. Then we have the next figure, we know, the plane figure, rectangle. These 2 lengths are equal, these 2 lengths are equal. Length and breadth, you can mark, right? Here the perimeter, you can write it as, here you have 1L, that will add up to 2L. Then 2 breadths. 2 B's. Then 2L plus 2B. Okay. Then we have the next plane figure we know. Triangle. I mark the lengths as L, B, and H. This could be this is not an equilateral triangle here. All the lengths are different here. So it is simply the marginal length. Then perimeter is adding up to L plus B plus H. Okay. Then we have a circle. This one we learned in grade 10, I think. Then you have the radius as R. Then we call this, a similar term is used when finding the perimeter of a circle. Here the perimeter is equal to circumference. Circumference. We call both the names to this, perimeter or circumference. Then P is equal to 2 pi R. All right. These things you have to remember. 2 pi R. Can you quickly write this down? I'll give you about 5 minutes. You can use a sheet of paper as I said. Now this side you can use to perimeter. Okay. You're done. Then the next is a sector. A piece of pizza from a circle, right? Then you have the radius here, and this is also the radius, and you have this arc length here. Okay. Now here you have two measurements to be taken. First one is arc length. Now the angle is given as 90 degree here. I'll just put theta instead. Okay. Then it will be theta out of 360, because the entire angle is 360, into 2 pi r. 2 pi r is the circumference. Then a portion. This portion represents, this angle represents out of this. How, what amount of length is represented by this in this angle, within this angle. If this angle is this much from 360, how much is it from the total circumference? Then that gives you the arc length. Not only the arc length here, we need to add these two radii as well. Then your perimeter will be arc length plus 2 radii, 2r. This is the equation for a sector. Okay, let's write down that one as well. Okay. Then that is all you have to learn about perimeter. That is all you have in your from your grade 6 to grade 11. Okay. That is about perimeter. Then we have to consider about the composite figures and all. We'll be discussing those questions soon after we discuss surface area and volume as well. Then the next one we have to discuss is surface area. Surface area of plane figures first. First we'll go with the plane figures, okay? Then as usual, we have the square, the rectangle, triangle, the parallelogram, then we have trapezium, okay? Then we have circle, then we have to consider a sector, okay? These are the plane figures that we'll have to consider. Now, if you take this area, you know, it's length into breadth. Length into breadth. Length is also A, breadth is also A, that will give you A square. Right? Then here it's also easy, L into B, length into breadth, LB. Here we know it's different, half into base into perpendicular height. Corresponding to that base. Perpendicular height, this one is very important. Corresponding to that base. To this base. Corresponding that. If you are taking this length as the base, you have to take the corresponding length as that, corresponding height as that. If you have to take this as the base, you have to take the height corresponding to that. Okay. Then here we have half B here, height here, perpendicular height, 90-degree angle. Then it gives you BH over 2. Okay. Then you have parallelogram. In a parallelogram, two opposite sides are parallel to each other. Right? Now here what you do, area is equals to the base into altitude. Base here is A, altitude is H. AH. Okay. Here, a trapezium. Here, parallelogram. Here you have trapezium. Okay. Then in a trapezium, how do you take the area? You multiply half by the sum of the two parallel lengths. Now these two are the parallel lengths. We are not adding these two. We are taking the two parallel lengths. These two are the parallel lengths. Then we are taking the sum of that. Then you have to multiply it by the altitude. Then we are half into L plus B into H. Number 2. That is for trapezium. Then you have the circle. The circle area equals to pi r squared, radius squared. Sector is EC, the angular portion of it. We multiply it by the angular portion into pi r squared. Theta over 360 degrees pi r squared. All right, now this is what you have to know when it comes to surface area of plane figures. Now we have 3D figures as well. Now for plane figures, that is what you need to know. Okay, I'll quickly touch down these points as well in a way that you can understand later. So from the next seminar onwards, we'll be sharing a tutorial or a tute for you to refer before class, and you can get some documents, some questions this week. Since it is a pre-class, I thought of doing it live like this for you to understand, so that you can write them down. From next week onwards, we'll be sharing some tutes for you to ease the work and reduce the time that we'll be spending on writing these. Okay. Okay. Now in these figures, in these three plain figures, you can't find any volume, as you know, nothing can be filled into that, right? These are plain figures. Then to find volumes, we need to have 3D figures, which will be discussed now. Okay. Now you can go on with a table like that. Then we are going to the 3D figures. First, we'll be discussing about the surface area. And volume. Here you will have the 3D figure. Okay, the first one we will be discussing is the cube. All the lengths equal. Then you know what the surface area is. Now, we know how to take the surface area of a single face. That is a square. Like that, you have 6 other faces in the diagram, in the figure. And you can simply multiply this by 6. Then you will have 6a square. Okay. Then what about the volume? Volume is always length into breadth into height. So here, you know, the length is A, breadth is also A, height is also A. Then you will have A cube as your volume. Then you are moving to cuboid. Now it is always important to take this base here. You have length here, breadth here, and height. Okay. Now, if you're going to consider the surface area, you have to know that this face and this back face, those two are identical. This face and this face, those two are identical. Then this top face and the bottom face, those two are identical. Then, when we are considering the area, first we have to consider these 3 of these faces. Then let's take this face first. Then you know how to find the area of this face. Length into breadth here is h. Then LH plus. Now you have 2 LHs here because you have this face and the backwards face. Then let's move on to this small face. That's B into H. 2BH because you have 2 such faces. Then this bottom face, L into B. Then 2LB because the top face is also similar to that. And this is how you take the area of a cuboid. 2 into LH plus BH plus LB. Sorry, someone talked. Can you talk again? Did you have any issue? If you have an issue, just talk. You can raise hand if not. Okay, then this is about the surface area of a cuboid. What about the volume? Volume is again always same as that. Length into breadth into height. Here you have length, breadth. Surface area of this base into height. It is always surface area. Should be volume, sorry. Here always, how do you take the volume? It is surface area of the base into height. Here surface area of the base is L into B into height, H, LBH. That is the volume of the cuboid. Okay, then we have cylinder. Okay, right circular cylinder. Write the name as right circular cylinder. And how do you take the surface area? You have two circular plates and a curved surface. Then to find the curved surface, we know if you elongate that curved surface, this circumference of this would be your length, 2 pi r. And this would be your height. I'll mark it here. This would be your height, right? Then we can take this this one as 2 pi r h. It is a rectangle. Plus, you have two circular bases. Then the area of a circular base is, we know, pi r squared. We have discussed already. And to that you can add 2 pi r squared. Then you can take 2 pi r out, h plus r. This is the area of a right circular cylinder. Then the volume of it, again, base area into height. Base area we know pi r squared, height is h. Pi r squared h. Okay, you can quickly write this down as well. I'll give you a few minutes. Okay. Let's move on to the next set of checks. You can take screenshots on if you couldn't write anything. Like, first of all, take a screenshot and later you will be having access for the recording as well. So yeah, don't worry about that. Yeah. Then our next set of objects. The next one we have is a right prism. Okay, the area and the volume of a right prism. You have the perpendicular height as h. You have three lengths here, x, y, z, and this length as L. Now here, you have two triangular faces, which will give you half Z. I'll make this B, it is here for you. B, half B, and the perpendicular height H. Two such faces. Plus, you have three rectangular faces. The first one, we can even go with an equilateral triangle here. Let's go with an equilateral triangle. Then all the sides are equal. B, B, B. Okay. Then you have three rectangular faces where you have the area L into B. L into B. Three such faces. Then here 2 cancel out. Then BH plus 3LB. Then what about the volume? Volume is again base area into height. Now the base is here, the base is this triangular face. We cannot take this rectangular face. Okay? Triangle is the face of this. Then you can take the area as half into base into height. Then the entire height is L. Then you have half BHL. That's for a right prism. The next one, right pyramid. With square base. That means something like this. Okay. The base is a square, which means all the sides are equal. Single side will be equal to A. Then the perpendicular height in the middle would be H, and the slant height would be L. Slant height, we call it slant height. Then how do you take the area of it? You have a single square face. The area is A squared. Plus 3, not 3, you have 4, right? 4 triangular faces, right? Now here also you have a 90-degree angle. Now it's this plus 4 into triangles. We know this perpendicular height is marked as L, one slant height එක කියලා කිව්වේ. Here the slant height is L and the base is A. Then what is the area of this diagram? It is half into A into, yeah. Then we have to multiply this by 4. A squared plus 2A, yeah. Then the volume you need to remember. Volume is 1/3. Now, the volume of a right pyramid with a square base is 1/3 of the volume of cylinder. Then 1/3. The volume of cylinder is A squared H. If the radius of the cylinder is R. Okay. This. It is a right circular cone. Next. Then in this cone, you have a face like this and a part like this. Where this is equals to this one is slant height L. Then you can take the area of this. For the circle, we know, since it's R, pi R squared, plus, for this we know, this is L, that is similar to a sector. If this angle is theta, it's theta over 360 into pi, you have L as the radius here, pi L squared. In this video, surface area of a right circular cone. Okay, now here there is another derivation part. I will do it here. Do it on this prism. I think you have taken a screenshot already. And for this one, we don't know the theta value. Normally, when a cone is given, we don't know the theta value. Then instead of the theta value, what can you do? Now, here we know into pi L squared is equal to this, right? It's 2 pi L. Sorry, 2 pi L. This is the arc length of it, and it should be equal to this because it is the curvature that the curved part is around the circle, right? Then it should be equals to 2 pi r here. This 2 pi r should be equals to this arc length. That is what I said. And you can cancel 2 pi from both the sides, and you don't know the value of theta, then you can keep theta in a single side. You have r here, 360 degrees. This can be taken here, and this can be taken downwards. Then you have found the theta value. This is how you find the theta value. Now, that is not what we want. We need to find the area of this sector. Then if you find the area of the sector, we know the area is theta over 360 degrees into pi L squared. Right? Then instead of theta here, you can substitute this part. 360 degrees R over L over 360 multiplied by pi L squared. This L could be taken downwards. That will be cancelled with this. 360 will be cancelled with this. Then you will have pi R L as the remainder. Then you can substitute this with that pi R L. This is the equation that you can use to find the area of a right circular cone. Okay. You can write this derivation as well, because that is very important. Rather than by hearting, you can simply get the idea of how the derivation have happened. Okay. Then the volume is easy. It is 1/3 of r squared h. You can take a screenshot or either write it down if you want. Okay, we have one last figure. It's the sphere. That one is easy. surface area would be 4 pi r cube, pi r squared. The volume should be 4/3 pi r cube. It's because the volume of the cylinder, if you fill a cylinder with a sphere, with a cone, it will give you the volume of a sphere. Here the cylinder pi r squared h minus. For the cone, you have 1/3 pi r squared h. Here h is 2r. Then you will get it as 4/3 pi r squared, pi r cubed. Sorry. Okay, so this is what you need to know. In these 3 lessons: perimeter. I take a screenshot of this. This is what you need to know in the perimeter lesson, surface area and also surface volume lesson. Okay. All right. Now we can try some past paper questions and revise the topic. Okay. Now from next week onwards, I'll be taking about 30 minutes or 45 minutes as for the revision session, and the rest would be discussing papers. Okay. Okay. Let me share some documents with you.
Okay, so this is the 2022 past paper. So we'll be discussing the questions in the 2022 past paper. Okay, I think the screen is visible enough. Can you give a thumbs up if you can see the screen? Would be helpful. Okay, great. Can you give it a try? I'll do the calculation. Those are more questions you can work on.
Yes. And as you can see in the question, this is a MCQ, okay, from 2022 paper. The arc length of a sector of a circle of radius 7 centimeter is 11 centimeter. What fraction of the circle is the sector? Okay, let's work on this together. Yeah. So in maths, it is very important to draw rough sketches when you are doing calculations. Okay, the first thing that you can do is dodging a rough sketch. Now it says the radius is 7 centimeter and there is a portion or a sector which the arc length is how much? 11 centimeters. So first of all, what you have to do is draw this figure. Okay. Then now what do they say? Now arc length is given, the radius is given. Then what fraction of the circle is the sector? They are asking for this part, right? That means this angle. What this angle is, that is the question, right? That is the question that they're asking. Which portion is this sector from this entire circle? Then you can simply put the arc length equation. How do you find the arc length? You take theta over 360 into the perimeter of the circle, which is 2 pi r. We discussed this. If you have the little note that we wrote, I told you. Now, I think it was enough for you to write the entire thing in a single A4 sheet, right? So that way is better, I think. When arc length it is given, then you need to find this angle 360 degree. No, then 2 pi r. Okay, now simply you can substitute. 11 centimeters equals theta over 360 into 2 pi 7. R is 7 centimeters. Instead of pi, what can you put? You can put 22 over 7. Then you can cancel these 7. Okay, then 11 centimeters. The next task is you have to keep this theta in a single side. Then you can take this 2 and 22 here. Then you will have theta over 360 remaining. Okay, then you can cancel these. Then you will have the answer as 1 over 4. Okay, now you have what you have to find is the theta angle. Okay, then here if you find the theta angle, theta equals to 360 multiplied by 1 over 4. That gives you 90 degrees. But this is not the answer they are expecting. What fraction of the circle is this sector? Then you have to write this as a fraction. 90 degrees over 360. That means 1 over 4, right? That is the answer. First we have to sketch the diagram. Then we know the arc length. We don't know which portion it is. We know the radius. Then you substitute all the values you know. Then find the theta like this, but this is not the answer they are expecting. They need it as a fraction. Then you have to convert it in the fraction form using the angles. Then the total angle is 360. 90 is 1 over 4 out of it. Okay, you can take a screenshot or either you can write it down. I'll give you 2 minutes.
I wrote teacher.
Sorry? Do you have any problem? Okay. Good. Then we have another question. We'll discuss the 2022 paper since it was the nearest paper. From next week onwards, we will be discussing papers from 2016 to 2022. So there will be 16, 17, 18, 19, 20, 21, and 22. So 7 past papers will be discussed. Okay, I'll be selecting some questions and putting them in the group as a document. So for you to read. Okay, then you have a second question, try it out. Okay. Then in the diagram, it is we need to find the value of AC first, right? Then it is a triangle and a sector combined. Then for the triangle, we need two lengths are given. We need to find this, right?
Recording in progress.
Okay, now you can see the question. There, you need to substitute or you need to use the Pythagoras theorem. Now, this is an additional part to the lesson today, but we already know Pythagoras theorem from our younger ages, okay? Then this length squared is equal to the squared addition or sum of these two lengths. Then AB, they have given a hint there. AB is 21. You can take it as squared. BC is 28 squared. Then 21 could be written as 4 by 7. Yeah, 28 can be written as 3 by 7. 4 by 7. Now they have given this hint for us to calculate easy. Okay, then we know from these now you can take the squares of this. We can remove this as keep as a constant here, and you have this and this. Then 3 squared is 9, 4 squared is 16. Then you will have 5 squared here, right? Then AC squared is equal to 7 by 5 squared, which is 5 into 7 squared. And it is AC squared. AC is equal to 7 by 5, which is 35 in here meters. meters. Okay. Then the second part. Okay. It is required to build a fence around the whole bed. Find the length of this fence. Oh, now this one is easier. You have, now are we taking this length? No, because it doesn't take part in the margin. Then we have 35 here, here 21. Here we have to find the arc length. We don't actually know the arc length. Here 28 means what is the radius? When you divide 28 by 2, you get 14 meters. Then first of all, let's write the arc length of here. Okay. Now the angle is 180. That is 180 over 360 is half. Half into 2 pi r. Instead of pi, you can write 22 over 7. Then to r, instead of that, you can write 14. You can cut these two here. 2 by 22 is 44 meters. Now you have this arc length as 44 meters. Then you can calculate the perimeter as 44 meters plus 35 meters plus this 21 all together. Now it will give 5 will give 0 here, then 1, 100 meters. Then in the third question, you are asked to find the area of the semicircular portion, only this part. Then area we know, pi r squared. Then theta over 160 here is half. Pi we know 22 over 7. R we know 14 by 14 r squared. Then you can simply cancel out these two like this. Then you can multiply. You have 22 by 40. 22 by 14 is 308 meters squared. Since it is an area, you have to write it as a square, m square. Okay, you can take a screenshot. Then the final part of this question. Fourth part. It is required
Recording in progress.
I'm using my other device to share the screen. That's why it's being lagging. Next week I'll be providing. I couldn't share it from this. I'll be providing you the PDFs as well as I'll be sharing it on this. Okay, then in the last question, the fourth one, it is required to add a rectangular plot that is of area equal to the area of semicircular portion with AB as a side. Then outside the triangular portion, draw a sketch of this rectangle with its measurements in the above figure. Now we found the area of the semicircular portion, which is 308 meters squared. Now it's like they need to add a rectangular portion where AB is a side. This should be a side. Now it should be like this then, right? Now we know the length 21 meters. Then we have to find this breadth area. Area equals to length into breadth. We have the length. We don't know the breadth. We know the area. Then to find the breadth, you can simply divide. Here, take it to here to find the breadth. Then you can find the breadth in this way. If you divide 308 by 21, you will get the answer as 50. 14.6 you get. Something like this. So it will be this breadth would be 14 and 2 over 3 meters. All right. Let's move on to the next question. Now this question includes some quadratic expressions and stuff as well. I'll be deriving the equations, just that, okay? I won't be solving. Yes, it is not required, like, it is not a part of our lesson. This is a combination of the area, surface area with the, with the quadratic expressions. Okay, let's give it a try. I'll be sending the rest of the years to do as homework for you to do as homework. I'll try to discuss the other papers since we are just doing 2 hours today. I'll try to discuss the rest of the papers in the next class. I'll spare some time for the perimeter discussion in the next class. Okay, now this one is quite easy. I'll just derive the expression. Now we have given the total area of these two. The question says the length of a side of a square lamina B lamina is 4 centimeters more than the length of a side of the square lamina A. A, it is more 4 centimeters higher than, lower than the B lamina. Okay. Then here we have to derive an expression by taking, we have given the addition of both the areas here, and we have to derive an expression to find the length of a side of lamina A. That means X. To derive, we have to derive an expression to find the answer for the X. Okay. Now let's derive. Area of A, we know it's X squared. Area of B, we know it's X plus 4 squared. Right? Then area we know 88 centimeters square. X squared, then plus X squared, then 4 into 4 is 60. Now this is the equation that you will have to solve in this question. All right. So let's move on to next page, 2020 paper. The 17th one is very easy. The right prism with a right triangular cross section is shown. Then underline the figure which is not the shape of a face. Then second one is the answer, right? Now, let's try this one. Then the arc lengths of the sectors of circle shown in the figure are equal. Arc lengths are equal. Then you have to find the value of R. R is the radius of the figure A. Then here let's write equations for arc lengths. Arc length of figure A, then arc length of figure B. Okay. Arc length of figure A, we have given the angle 45 degrees over 360 into 2 pi r. Pi is this. We can just simply write pi here. R is capital R. We don't know. Here it is 90 degrees over 360. 2 pi, then R is given as 7. Then arc lengths are equal. Equalize these two. Okay. Now 360 you can cancel. 45, 2. Then you can cancel 2 pi, 2 pi. Then you will have R remaining in this side. 2 by 7 is 14 centimeters in this side. This would be the answer, please. You can take a screenshot or write it down quickly. Okay. Then are we sharing the other questions or the other papers with you all soon in the group that we will be having? So you can work on those questions and you can get prepared for the next class. Then you can work and get enough hands-on experience on these questions. Then we can discuss these questions in the next class. I'll be sure to make some time for this perimeter and surface area and volume questions next week. So we'll be covering these parts in the next week. So we discussed one past paper, almost 1.5 past papers today, and the questions regarding these topics that we discussed today. So I think you can share the class with your friends and you can get along and join for the next seminar series that we will be conducting. And we have a plan to do some paper discussions as well along with the seminar series. So yeah, thank you for joining, and I'll end the class for today. Let's meet from the second seminar.